Okay, that is redox reaction. Okay, so let us see how this is a redox reaction. This is total redox reaction. So in this particular reaction, we have oxidation reaction and reduction reaction also. Okay, so if you will observe the reaction carefully, on the reactant side, we have neutral species. There are no charges, positive and negative. But on the right hand side, in the products, we have charged species, positively charged and negatively charged species. Such reactions are redox reactions. Okay. Now see what is happening if you observe the reaction. Mg is converted into Mg2 plus. Mg is converted into Mg2 plus. Okay. And O2 is converted into 2O2 minus. O2 is converted into 2O2 minus. Means magnesium is acquiring 2 positive charges. Okay. And oxygen is acquiring 2 negative charges. Now you know electrons are negatively charged. Electrons are negatively charged. Okay. So if magnesium is converted to Mg2 plus, at least 2 positive charges are appearing on oxygen. 2 positive charges are appearing on magnesium. 2 positive charges are appearing on magnesium atom means that particular magnesium atom has lost 2 negative charges. As 2 positive charges are appearing on magnesium atom means in any atom protons, neutrons and electrons are present. So when Mg is converted into Mg2 plus in this reaction, 2 positive charges are appearing means 2 negative charges, 2 electrons are lost by magnesium atom. Loss of electrons is nothing but oxidation, and therefore we can say that magnesium has undergone oxidation. What we can say? Magnesium has undergone oxidation. Okay. At the same time, oxygen, if you will observe, okay, neutron oxygen molecule is converted into negatively charged atom. Oxygen has 2 negative charges. So it is converted from neutral species to a species having negative charge. That means in this reaction, oxygen has accepted negative charge. It has gained electrons. So gain of electrons is nothing but reduction, and therefore oxygen has undergone reduction. Oxygen has undergone reduction. So oxidation and reduction reactions are taking place simultaneously in this reaction, and therefore this reaction is redox reaction. Actually, it is made up of 2 reactions, isn't it? Redox reaction is made up of 2 reactions: oxidation, reduction. So what we will do now? We will write first of all oxidation half reaction. Then we will write for the same reaction reduction half reaction. Then we will add both the reactions and we will write the final reaction, which you will observe the same one. Okay. So first of all, we will write oxidation half reaction. So Mg is converted into Mg2 plus, that is oxidation. So Mg is converted into Mg2 plus, and what will come to the product side? It has lost electrons also, na? And because of that only positive charges are appearing. So Mg2 plus plus Q minus. Mg giving Mg2 plus plus Q minus. This is oxidation half reaction. This is oxidation half reaction. Okay. At the same time, the electrons which are given by magnesium, they are accepted by oxygen, isn't it? So what will be the next reaction? Reduction O2. It is taking electrons, it will become plus 2E minus, giving 2O and 2 minus. 2 electrons are accepted by oxygen and it is converted into oxygen in ionic form. 2O, 2 minus. 2 electrons are given, 2 electrons are accepted. The reaction is balanced in terms of electrons. If 2 electrons are given, the same number of electrons will be taken. It will never happen that 2 electrons are given and 1 electron is accepted, or 1 electron is given and 2 electrons are accepted. So, if we add oxidation of reaction, this is reduction half reaction. Reduction half reaction. After adding electrons given and taken, they will get cancelled, and overall reaction will be Mg plus O2 giving Mg2 plus 2O 2 minus. So this reaction we are getting back. So this particular redox reaction actually is a combination of oxidation half reaction and reduction half reaction, and finally we are getting redox reaction. I hope you must have understood what is redox reaction with the example which I have taken. Okay, now we will go to two more terms. Oxidation and reduction we have seen. Now we will see what is oxidizing agent and what is reducing agent with the help of same example. Okay, which terms you are going to see now? After oxidation, loss of electrons. So now we will see oxidizing agent, and after that we are going to see reducing agent. Now agent, you know, agent is the one who helps, isn't it? Agent is the one who helps. So oxidizing agent is the one which helps others oxidation. Oxidizing agent is the one, oxidizing agent is the species which helps others oxidation. Means it helps others for their oxidation. Oxidation is loss of electrons. So oxidizing agent forces others to give electrons. How? It is helping, no? So it has to accept electrons so that the others will give, isn't it? So oxidizing agent, oxidation is loss of electrons. Okay, but oxidizing agent makes others to lose electrons by accepting electron itself. So oxidizing agent, okay, it is undergoing reduction. At the same time, reducing agent, reduction is gain of electrons. Reduction is gain of electrons. So reducing agent which helps others reduction, means it is helping others for gain of electrons. It is helping others by gain of electrons, means it itself is losing electrons. So reducing agent, it undergoes oxidation. Okay, we will apply this to a particular reaction which we have taken. Okay, here magnesium is undergoing oxidation. Magnesium is undergoing oxidation. Okay, means it is losing electrons. At the same time, it is helping oxygen for its reduction. It is helping oxygen's reduction, because oxygen is able to take electrons because of magnesium. So magnesium is reducing agent. Magnesium is helping reduction of oxygen. Na? So magnesium is reducing agent. The species which undergoes oxidation is reducing agent. At the same time, oxygen is accepting electrons. Oxygen is accepting electrons, means it is helping magnesium to give electrons. It is helping magnesium to give electrons, means it is helping magnesium for its oxidation. It is helping magnesium's oxidation. So it is a oxidizing agent. So the species which undergo oxidation is reducing agent, and the species which undergo reduction is oxidizing agent. Okay, so which concepts we have seen? Oxidation we have seen, reduction we have seen, total redox reaction we have seen, then oxidizing agent, that concept we have seen, and reducing agent, that concept also we have seen with the help of same example. Now we will take one more example and we will apply the terms to that particular reaction. For example, CaF2 giving Ca2 plus 2H minus. Charges are there, isn't it, on the product side? So CaF2 giving Ca2 plus 2H minus. If this is a redox reaction, this is a redox reaction. We are going to cross check now whether it is a redox reaction or not. Whether it is under, there are two steps, oxidation half reaction, reduction half reaction. And after adding them, whether we are getting the same reaction. So if you observe the reaction, Ca is converted into Ca2 plus and F2 is converted into 2H minus. Isn't it? So Ca positive charges are appearing, so it has lost negative charges, electrons, loss of electrons is oxidation. F2 is converted into F minus, so negative charge is appearing on fluorine. So fluorine has accepted electrons, negative charge means acceptance or gain of electrons is reduction. We will write now individually oxidation half reaction and reduction half reactions. Ca giving Ca2 plus. Two positive charges are appearing means two negative charges are given plus 2E minus. So this is oxidation half reaction. Okay. At the same time, the electrons which are given by Ca are accepted by F2. So F2 plus 2E minus giving 2F minus. F2 plus 2E minus giving 2F minus. So what it is? Acceptance of electrons, reduction. Reduction half reaction. And electrons which are given are taken. So we can cancel them. After addition of these two, Ca plus F2 giving Ca2 plus 2F minus redox reaction. Is this the same as original reaction which was given? Isn't it? So this particular redox reaction involves oxidation half reaction and reduction half reaction. Now let us see which is oxidizing agent and which is reducing agent. In this reaction, Ca has lost electrons. Ca has lost electrons means it has undergone oxidation, but at the same time it is helping, it is acting as agent. It is helping fluorine's reduction. Fluorine can accept electrons because calcium has given, no? So calcium is helping fluorine for acceptance of electrons. Means it is helping fluorine's reduction. It is acting as reducing agent. Calcium is acting as reducing agent. What about fluorine? Fluorine is accepting electrons. So it is undergoing reduction. It is undergoing reduction. Okay. It is able to accept electrons because calcium has lost electrons. So actually what fluorine is doing? Fluorine is helping calcium's oxidation. Fluorine is undergoing reduction itself, but at the same time it is helping calcium for its oxidation. So fluorine is oxidizing agent. Fluorine is oxidizing agent. So what you can conclude? The species which is undergoing oxidation is reducing agent, and the species which is undergoing reduction, gain of electrons, is oxidizing agent. Okay, now we will continue the chapter in the next video. Thank you.